Dynamic 6-1 notes. Here we go. Show on the road. All right, guys. Factoring never goes away. Just so you know. And we'll see that today. Yeah, don't worry.
Why did Mr. Rush go? Where did he get our test graded?
Hoping to start them tonight.
Okay.
I got one other thing to do, and then the tests. I got 2 preps at the end of the day, and then I got 2 preps at the end of the day, and then I'm hoping after school. Yeah, it's supposed to be a kind of a weather nut. There's supposed to be like a tornado outbreak today in Mississippi, so I think I'll go home, put the AirPods in, get a cup of hot chocolate, start grading. You got a lanyard? Yeah, in Mississippi. See if you have anyone, you know anyone in Mississippi. All right. What was I going to do? Yep, so we got the notes. Good. Mississippi, yep. Oh, that's what I was going to do. Sorry, I just can't remember anything. Let's look up when your guys' quiz is. Because I had that on Schoology as well. I have Tuesday the 6th for you guys, so next Tuesday. So a week from today. Quiz over the 6-1 through 6-5. Ooh, that's kind of ambitious. We'll get through it. Okay, cool. So first lesson, this chapter is all about what are called rational functions. Rational functions, okay? See that right here, rational functions? Okay. These here are rational functions. So a rational function is like a fraction of 2 polynomials, basically. That's the best way to describe it. Okay. So it's a fraction where the numerator and denominator are both polynomials. Okay? So here we got a linear polynomial over a constant, quadratic polynomial over a linear polynomial, and then 2 linear polynomials. Okay? That's a rational function, okay? Special stuff happens with rational functions, okay? So first thing we're going to talk about is the domain of a rational function. Does anyone remember what domain is? Yeah, so it's all the x values, right? It's all the x values that you can, that you are able to, that you are indeed capable of plugging into a function, okay? So this is going to, the domain of these is going to be the set of all real numbers except for what we call the excluded values of x. So we'll have to exclude those. But other than that, our domains are going to be all real numbers. Hey, gang. All right, thank you. Just leave it right there. All right.
The highlights and
all right. No worries. All right. Okay. So you might be asking yourself, okay, how do we find the excluded values? How do we find these? How do we find the excluded values? What the heck are those? Okay, so how do we find these? Okay, to find them, okay, so to find excluded values, to find our excluded values, okay, you set the denominator equal to 0 and solve for x. Okay. So when we're finding the domain of, let's look at part A. When we're finding the domain of that, we need to take, it's going to be all reals except for the excluded values we find, okay? So the excluded values we find, I'm going to highlight the denominator here. Cool, I just highlighted it. We're going to set that equal to 0 and solve for x, okay? So 4 equals 0. That has no solutions, right? No solutions, right? So there's no excluded values. So what would my domain be then? If it's all real numbers except the excluded values and there are no excluded values, what's my domain here? It's just all real numbers, right? We're going to do interval notation again, okay? How do I write all real numbers in interval notation? Yes, it's negative infinity, comma, positive infinity, okay? All right, cool. Let's find the domain of this second guy here. So I'm going to highlight that denominator in yellow. Okay, so I'm going to take that denominator and write the denominator equals 0, and I'm going to solve for x. What do I get when I solve for x here? 0. I get 0. X equals 0, so that's my excluded. That's my excluded value. So then my domain is what? What's my domain going to be?
0, 0.
Exactly, yeah, so it's going to be all real numbers except for 0. And Tom just hit the nail on the head. And interval notation, right? We write that as negative infinity, comma 0, with parentheses union 0 to infinity, 0, comma infinity, okay? So that's our answer for the domain. Okay? And the parentheses mean that 0, that the endpoints are left out of our domain. So 0 is not in our domain, okay? All right, but everything else is. Can I move on to part C? Can I move on to part C? Part C. Okay, negative 7. I'm going to take the denominator. Again, I'm finding my excluded values. Take the denominator, write it equal to 0. Solve for x. So x equals 7 is my excluded value. So my domain is going to be every real number except for 7, okay? And again, I write that in interval notation just like I wrote the last problem. Okay? Negative infinity to 7, union 7 to infinity. Okay? Okay. All right. Let's do D. Let's move on to part D. I'll erase a little bit of this. Part D, I'm going to do what? I need to find the excluded values. How do I do that? Just highlight the bottom. Set it equal to 0. Write it 7x plus 5 equals 0, and I solve for x on that. Okay, so that's my excluded value. That's my only excluded value. So my domain is going to be what? So my domain will be every real number except for that excluded value, negative 5 over 7. I write that in interval notation the same way we've been doing it. There you go. There you have it, right there. How are we feeling about this? It's pretty straightforward so far. Okay. All right, let's do this second one. Oof. Factoring never goes away. So what do we do here? It's just like the other problems. So yeah, so we're gonna take that bottom and write the bottom, the denominator, equals 0. Then we got to solve for x, right? So now we're solving this blue equation for x. Do you see how this is? There's a lot of review from the last chapter here. Okay, this is just like those problems we did in the last chapter. Okay, so we got to make sure it's in standard form. Am I in standard form? Yeah. Second step is to factor. Okay, so are there any GCFs? No GCFs. And look, that lead coefficient is not 1. Face. That face. Okay. So I'm going to write down all the factors of that first number, all the factors of the second number. Wait, sorry. All right, I'll set up my little shell, as I like to call it. sign's going to be? Plus and minus, yeah. Remember, difference, so that product of the outer and the product of the inner should have a difference that's equal to this coefficient of 1 in the middle. Okay, so if I multiply these outer numbers together, that gives me 2. If I multiply the inner numbers together, that gives me 3. And I want a positive or a negative left over in the middle. Positive left over in the middle. So that 3 needs to be positive, or the 2 needs to be positive? The 3, the bigger one, needs to be positive. Okay, and that 2 needs to be negative. So what I'm going to do, right, the 2 times 1 needs to give me a negative 2. So this 1 here is going to go next to the minus symbol. This 1 is going to go next to the minus. Okay, and then I have to multiply 1 with my 2, so I'm going to write the 2 in the other outer spot. Okay, and then I just have 1 spot left for the other 2. That's factored all the way, good. How do I solve for x now? What's my last step? I set each factor equal to 0 and solve, okay? So that first one will give me what? Negative 3 halves. Okay, and then the second one will give me 1. So I'm going to circle these with a dotted line because this isn't my final answer, right? The final answer is going to be my my actual interval for my domain, and we just found the excluded values, okay? But once we get to this step, what do we know the domain's going to be? Yeah, so it's going to be all real numbers except our 2 excluded values here, okay? So we do this the exact same way. We write excluded values in our domain the exact same way we've been doing it, okay? So we're going to go negative infinity, comma, negative 3 halves, okay? Union, negative 3 halves to positive 1. Union, oh gosh, I'm out of space. Negative 3 halves to infinity. There you go. Okay. So notice here, right? Oh, sorry, that should be a 1. That should be a 1 right there. This should be a 1. Sorry, guys. Okay, sorry about that. So just notice, right? To exclude, or we just write our excluded values with parentheses and a U. Okay. All right. So we want to write all real numbers except negative 3 halves and 1. So the way we do that is with parentheses and a U. Okay. Are we following? Okay, cool. Good stuff. Can I move on to A? Can I move on to 2? I can, okay. Cool stuff. Okay. So for simplifying rational expressions, what we do is, okay, there's 2 steps here to simplifying these, okay? Ooh. That's cool. 2 steps, okay? First step is you find the excluded values. Second step is you factor and cancel. So let's do that first step then for part A. What are the let's find the excluded values for this. So I'm just going to take the denominator, write it equal to 0, and solve for x. That gives me x equals 0. That's excluded. Okay. Okay. Then my second step is I factor. So I'm going to factor the top and I'm going to factor the bottom. Okay. What does the top factor to? Yeah, so I'm going to pull 2x out. It's going to be x minus 3, right? 2x times x minus 3. And then the bottom doesn't factor at all. And then do you guys see what cancels out there? You guys see what cancels out? Yeah. So this is equal to x minus 3. Okay. Well, it's equal to x minus 3. I'm going to put an asterisk there. Why do you think I have my asterisk there? Is that? So I put an asterisk there, right? Because, right, we could say that this function is equal to the function x minus 3 except for what? What's going on? What's the difference between those two functions? What's the difference between... So their graphs are going to look the exact same except for what? The graphs of these two functions are going to look the exact same except for what? What's that? What are the excluded values of this top function? What are the excluded values of this function? There's none. There are none. So, okay, yeah. So if I were to graph the line x minus 3, just that, like original function, that has no excluded values, right? A line doesn't have... x minus 3 is going to be the line that looks like this. Okay? Okay? This other function, I'll do it in red, this red function here, its graph is going to look the exact same, except when we get to that excluded value of 0, at x equals 0, there's going to be what's called a hole. There's going to be what's called a hole in the graph, okay? So the graph looks almost the exact same, except x minus 3 has a solid dot here, and 2x squared minus 6x all over 2x has a hollow circle there. So I just want to make that little point. That's a little conceptual understanding I want you to have, okay? But this is our answer. This is our answer. That's why we also need to circle the excluded value. So it's equal to here except for this excluded value. Does that make sense? The function is the exact same as x minus 3 except for this one value that gets excluded from the original function. Okay? There's one. Yeah, there's two parts of one answer. Yeah. Another note I want to make. Let's do this as a third step. Let's make the note sometimes it's easier to factor and then find the excluded value. Right, it doesn't matter what order you do everything in, just as long as you get the right function and the right excluded values at the end. Okay, so let's move on to part B, okay? So let's find the excluded values here. This one's pretty easy. We don't have to factor first. We just set the bottom equal to 0. So x minus equals -9 is excluded. Right? That's not part of my graph. That can't be part of my graph. Right? If I plug in -9 here, I get divide by 0, which we can't do that. Okay? So that's excluded. And then I do what? Factor and cancel. What does the top factor to? No, it's not. Oh, wait. No, it's not. It's not a perfect square. There you go. Yep, they've got it. Factors to x minus 9 times x plus 9. Okay? And then do you see what cancels here? Yeah, so because it's an addition, x plus 9 and 9 plus x are the same thing. So this is x minus 9. X minus 9 with that -9 excluded. Okay. So we wrote the excluded values and then we factored and canceled. Okay, how are we feeling? Feel okay? C, this one is going to be one that's easier to factor and then find the excluded value, right? And that's because, right, to find where the bottom equals 0, you have to factor anyway, okay? So we're going to go ahead and factor first, okay? This one is kind of a bear, so bear with me. All right, let's factor the bottom, because that one's not too hard to factor. What is the bottom factor? Do we have any GCFs on the bottom? I don't see a GCF. Not among all four terms, right? Because 3 is prime. 3 is prime, so there's not going to be any GCFs in the bottom. So what kind of factoring method do I do when I have 4 terms? Grouping. Yeah, I'm going to do a grouping. Okay, so let's group. Okay, so I'm going to draw red parentheses around the first two. I'm going to draw blue parentheses around the third and fourth terms. What can I pull out of that red parentheses? X squared. Yeah, I can pull x squared out of there. What can I pull out of the blue? Can't pull anything out, right? 1 times 2x minus 3, then what's my final answer? Yeah, final answer then is, yeah, x squared plus, so it's 2 parentheses. Final answer is 2 pairs of parentheses. One is we just copy down the matching binomial here in both terms. The other one is we copy down the coefficients. Okay. That should be review of last chapter. So the bottom factors to this. And we're done factoring at this point, okay? Sum of squares can't be factored anymore. That's prime. So we're done factoring at this point. Okay. And then let's factor the top. Ugh. Okay. So are there any GCFs in the top? No. So we got to do the old-fashioned way. Sad face. Sad face. Okay. All right. So let's write down the factors of the first number and the factors of the second number. Set up our little shell, as I like to call it. I'll do it up here. What are my signs going to be? Plus and minus. Yep. So I want the difference of my outer and inner here, the difference, to be equal to that 1 in the middle. That minus 1 in the middle. Right, there's technically a minus 1 there. Okay. So that pair doesn't work. So I need to flip the second pair. 3 times 1. Okay. So then outer 2 times 1 is 2. Inner 1 times 3 is 3. 3 minus 2 is 1. Good stuff. So this is going to work. This pair is going to work. Okay, the outer numbers multiply together to give me 2. The inner numbers multiply together to give me 3. I want a negative 1 or a plus 1 left over. So the 3 is going to be negative or the 2 is going to be negative? The 3 is going to be negative. Okay, so the inner numbers, that 1 and 3 on the inside, need to multiply together to give me negative 3. So I'm going to put this 3 here next to the minus sign. This 3 is going to go right here next to the minus sign. Okay. So then that 2, that 1 needs to get multiplied with my 3, so it's got to go. This 1 has to get multiplied with 3, so the 1 has to go in the other outer spot. Right, the outers get multiplied together, the inners get multiplied together, and then there's 1 spot left for the other 2 numbers. So I can just fill those in. Good. All right, so we factored it. The top's equal to x plus 1 times 2x minus 3. Okay? So at this point, then, I can find my excluded values, right? The excluded values for this function, right, if we highlight the bottom, the excluded values are if we set the bottom equal to 0. Okay? Okay. So how do we solve this equation here? What do? It's already factored and everything. We just set each factor equal to 0 and solve, okay? So x squared plus 1 equals 0. Does this have any solutions? No, it doesn't. That has no solutions. So we'll X that out, and then we'll set the other one equal to 0. Okay, that gives us okay, so x equals 3/2 is excluded, so let's circle that. That's part of our answer. So we got an excluded value of 3/2. Okay, so there's a lot going on in this problem. But it's nothing, that's just because we had to do a lot of factoring first, okay? And then I do what? What's my final step here?
Why is the first one crossed out?
There's no solutions. X squared plus 1 never equals 0. Yeah, because x squared is always positive and 1's always positive, so if you add two positive numbers, you can't get 0. Yeah, so that's why it's crossed out. It's no solutions. No solutions here. Okay, then what's my last step here? So I already factored, so I just have to do what? I just have to cancel. So that's going to cancel. So my final answer is just going to be what's left here. Okay, so x plus 1 over x squared plus 1, right, with those excluded values. Okay, so what this means is the graph of this original function here looks just like the graph of this function, except x equals 3/2 is excluded from the domain. And this, if we were to graph this function, there'd be a hole in the graph right where 3/2 is. Okay. All right. Let's continue here. The rest of these aren't too bad. Okay. Can I do D? Can I do part D? Okay. I'm going to move on to part D. So yeah. So that last problem, like it seemed like a lot, but it was just following the exact same steps. It was just hard because we had to factor. We had to do 2 factoring problems within that for that one, just for that one example. Okay, so that's why, like it's still a simple process. There's just multiple parts. Okay, so here, what are my excluded values? This one's easier. We just set the bottom equal to 0, right? We write the bottom equal to 0, and we solve for x. Okay. So x equals 8 gets excluded. Okay. And this is a lot easier because it's a lot easier to factor. The bottom can't factor. What does the top factor to? Close. Yeah, there's 2 parentheses. So there's a difference of squares. It's a difference of squares. Yeah, Ava?
X plus 8
So you guys are both really close. In the first part of the parentheses, I put the square root of the first term. The first term is 64, so it's actually 8 plus x and 8 minus x. Do you see the difference there? You guys see the difference? So it's 8 plus x and 8 minus x. Okay. All right. So then what cancels here? What cancels here? So that 8 minus x and x minus 8, they're almost the same thing, right? Here's what goes on. Here's what happens, okay? If you have, in general, if you have a minus b over b minus a, that's going to equal -1, okay? So these 2 terms here will cancel with an asterisk. They'll cancel, but they'll produce a -1 when they cancel. So my final answer is -1 times 8 plus x, or just -8 plus x. What's that? Produce a -1 because it's a subtraction. They're both a subtraction. They're binomials with a subtraction sign, but and they're backwards. They're like reverse of each other. That's why.
So if they were reversed,
Then it'd just be 1. Yeah. And right, that doesn't matter with addition because like x plus 8 equals 8 plus x, but subtraction does not work the same way, right? 4 minus 2 is not the same thing as 2 minus 4. Okay, they have different values. Okay, so when those cancel, because they're subtraction and they're like flip flops of each other, they produce a -1 when you cancel them. Okay. All right, it's called factoring out a negative. Okay, can I move on to E? But that's the answer though for D, so not too bad. Can I move on to E? So E, this is going to be one that we want to factor first, right? Because if we set the bottom equal to 0, we'll have to factor it anyway to find the excluded value. So let's just factor the top and bottom first. Okay. Okay. These actually aren't too bad. Let's factor the top. Are there any GCFs there? Nope. So I'm going to set up my shell. The lead coefficient is 1, so we're happy. Okay. What are my signs here? They're both plus. Okay. So same sum. So I want 2 factors of 6 whose what is equal to 5? Sum, yep. So 1 times 6 and 2 times 3, 2 times 3, okay? So that factors to that. Let's factor the bottom. Any GCFs in the bottom? I don't see any. I do not see any GCFs. So let's set up that shell. What's the sign? What are the signs going to be here? Both plus. Okay. Same sum. So we want two factors of 21 whose sum is 10. That's 7 and 3. Okay. So let's do our excluded values now, right? What are our excluded values going to be then? What's that? Yeah, negative 3 is going to be 1, right? We set the bottom equal to 0. So it's going to be y plus 7 equals 0. Solve for y. And y plus 3 equals 0. Solve for y. So these are our excluded values. Those values get excluded. And then our last step is what? We just cancel this identical factors, okay? So our answer is y plus 2 over y plus 7 with negative 7 and negative 3 excluded. Okay, does that make any sense? All right. F I skip with B theory just to save time. Let me see. Let me factor on my own real quick and see how important it is to do this problem. Oh gosh, there's no response. This is equal to 4 times y minus 4. Same, opposite, always positive. Yeah, so this one's not too bad actually. So I factored the top and bottom using SOAP. And then my excluded value right here, I set the bottom equal to 0, so that gives me 4 times y minus 4 equals 0, or y minus 4 equals 0, or so y equals 4 gets excluded. Okay, and then when I cancel those, so my final answer is y squared plus 4y plus 16 all over 4 with y equals 4 excluded. Okay. I just went through that one. Okay, these next 6. Okay, these are the same thing. These are the same thing, except we have to, so we're going to simplify, right? We're going to simplify down here just like we did up here, okay? So we're going to follow these same steps. We just have to multiply these together first, okay? Okay, how do I multiply two fractions together? Just straight across, yeah. So here's how I'm going to write it. I'm not going to distribute anything. So I'm just going to write 8x squared times 3x minus 3 all over x times 5x minus 5, okay? So I just multiplied straight across. I didn't distribute yet, though, okay? Why do I not want to distribute? I'm going to have to factor pretty soon, aren't I? So if I distribute this 8x squared and I distribute this x here, that's just going to give me more work later on, and I don't want to have to do that, okay? Okay, so I wrote that down, okay? Now I'm going to factor the top and bottom. How do I factor the top? Is there a GCF there? Yeah, there's a GCF. There's a GCF inside these parentheses here, so I can pull a 3 out. So that factors to 24x squared times x minus 1, okay? What do I pull out in the bottom? A 5, yeah, so that's 5x times x minus 1, okay? And then before we cancel, what are our excluded values? So we take the bottom, we write it equal to 0, so 5x times x minus 1 equals 0. We got to solve that for x, right? So I just take each individual factor and I set it equal to 0, okay? So 5x is a factor, so I write 5x equals 0, all right? And then x minus 1 equals 0. Okay, so don't forget, guys, when there's an x outside here, that's a stray bell, I think. When there's an x outside here, you still got to set that equal to 0, okay? So these are my two excluded values. Okay, and then the last step is we just cancel everything, right? So these two guys are going to cancel. What else is going to cancel here? Yeah, so that x and that x squared are going to cancel one time, so we're going to have 24x over 5. It's going to be our answer. Okay? That'll be our answer. All right, let's do the same thing here with b. This is going to be equal to 24xy squared times 3x minus 21 all over 8x squared y squared times x squared minus 49. I'm not going to distribute. Okay? So this is one where you want to factor before finding the excluded values. How do I factor the top? So I can pull a 3 out of here. Okay? So this is going to be equal to, what's 24 times 3? 72. It's going to be equal to 72 xy squared times x minus 7. All right, how do I factor the bottom? X squared minus 49. You guys know how to factor that. Yeah. Yeah. So I'm factored, okay? So then my excluded values, I'm going to highlight the bottom here. I'm going to set it equal to 0. Okay? So how do I solve that pink part that's equal to 0? What do I do? Yeah, set each factor equal to 0, yeah. So x minus 7 equals 0. That gives me x equals 7. X plus 7 equals 0. That gives me x equals negative 7. Okay. And this final one, 8x squared y squared equals 0. What value that you plug in for x makes this equal to 0? 0, right? What about what value that you plug in for y can make it 0? 0, yeah. So what's going to happen is x equals 0 is a solution to that equation, and y equals 0 is a solution. So all 4 of these get excluded. Okay? Angry face. And then my last step is what? Just cancel. So these two are going to cancel. Okay? Other stuff's going to cancel, right? We're basically doing, these are like problems from the first half of last chapter where we simplify exponents. Okay? So that x is going to cancel with this x squared in the bottom. The y squareds are going to cancel. Then 72 over 8 equals 9. So we're going to have 9 over x times x plus 7. Yeah. That's my final answer. Okay. Okay, so that's a lot of this is just review of last chapter. We're just using what we learned to do other problems. Yeah. Yeah, it's hard. All right. Okay, so I'm going to multiply this one for C. I'm going to multiply across the top. Multiply across the bottom. This one's a bear. Okay. So I'm going to factor the top and bottom now. So I'm going to factor this trinomial here. What does that trinomial factor to, the green one? So x plus, plus. Okay, that green trinomial will factor. And then how do I factor this x squared plus 3x? What do I do with that? I pull out a what? I pull an x out of that. Okay, so I'm going to highlight that in purple. Okay, so I'm going to color code this. So this gives me x plus 3, and then there's an x over here. There you go. And then I'll factor this trinomial. What does that factor to? Yep, thank you. Yep, so that's what that factors to, and then I'll highlight this last one. I'll do it in blue. That last trinomial there factors to 9 and 2. Sweet. Okay. So there's the factored form. What are my excluded values going to be then? It's going to be, right, anything that we can plug into the denominator that makes it 0, okay? So basically we're just setting each of these binomials in the bottom equal to 0, okay? So we're doing x plus 3 equals 0. We solve for x. Okay. Okay. So these get excluded. All 4 of these get excluded. All 4 of those guys get excluded, okay? And then we cancel, okay? So what cancels here? There's a lot of stuff that cancels. The x plus 2's cancel. What else cancels? The x plus 3's cancel. What else cancels? The x plus 5's canceled. So we're just left with this x and this x minus 9. So the final answer is x over x minus 9 with these guys excluded. Okay? So there's a lot going on, but we're following those same steps, right? We're multiplying, and then to simplify, we're factoring, finding the excluded values, okay, and then we're canceling. So it's still just factor and cancel. I think we're probably intimidated because there's just a lot of factoring to do. There's just a lot of factoring. All right, this next part, divide and simplify. Dividing fractions is just like multiplying them, except what? You got to do what? What's that? So when you multiply 2 fractions, or divide 2 fractions together, you actually do what? You multiply by the reciprocal, okay? So we just flip the second fraction and change it to a multiplication. Okay, now at this point it's just like the last set of problems, right? It's just multiply and simplify again. So this is equal to 4x squared times 40 over 5 x cubed. So we don't really have too much factoring to do, right? I guess I should say it's equal to 160 x squared over 5x cubed. What is our excluded value going to be? So we set the denominator equal to 0. We write the bottom equals 0. Okay, that gives us x equals 0 is excluded. Okay. And then I just got to cancel. What cancels here? So the x squared cancels with the x cubed, so leave just an x on the bottom. 160 divided by 5 is 32. It's 32. So the final answer is 32 over x. Right, with this guy excluded. Okay. Let's do B. Let's do B real quick, okay? So this becomes, right, instead of having a division, we just change it right off the bat. It's going to be, instead of dividing by this second fraction here, we're going to multiply by its reciprocal. Okay? We're going to multiply by the reciprocal. Okay? So let's factor all 4 of these. Okay, so let's, like this in orange, let's factor that. I'm going to have to go through this pretty fast, guys. Sorry about that. So the orange factors to 3, no, it factors to 6 and 1. Okay. the green, I'm going to highlight this next guy in green. The green factors to what is that? Plus 3 and 4, x plus 3 and x plus 4. And then we'll draw a fraction line here, okay? The purple, just leave it right there. The purple factors to 6 and 3, okay? And then that, I'll do blue. That blue guy right there factors to x plus 1 and x minus 1, okay? So it's just a lot of factoring, okay? Just a lot of factoring to do it. So I multiplied across. What are my excluded values going to be? Yeah, so I just set each of these equal to 0. So it's going to be x equals negative 6, x equals negative 3, x equals negative 1, and x equals 1. These get excluded. Okay. And then what cancels? So the x plus 3's cancel, the x plus 6's cancel, the x minus 1's cancel. So we're left with x plus 4 over x plus 1, with these guys excluded. Okay. So that's it. I'll skip C. It's just another example of this. I want to get to this word problem. Okay. So 5, a company's cost per book for printing X particular books is given by this rational function. Find the cost for printing 300 books. Let's start with that first one. What do I do then? All I do is I just take this 300 books and I just plug it in for X, yeah. So C of 300 equals 0.8 times 300 plus 5,000 all over 300. Let's use our calculator to do that. I got 1747. Right? Make sure you put a dollar symbol and round to the nearest cent. Is that what you guys got? No? Yes? No one did it? Okay. Well, that's what I got. And then what do I do for 3,000 books? Just leave it there. What do I do for 3,000? Yep, same thing. You just plug in 3,000. Oh, it should be over 3,000, right? Sorry, a little typo. And I got 247. Okay. So that's it for this lesson, guys. Good job. Good work today. Homework is on Schoology. Okay, so it's book problems, okay? Good job today, guys.